welcome. We are looking at chain rule. So in calculus, chain rule is one of the most important concepts used in calculus. It is one of the most important concepts that's applied in both integration and differentiation. So let's look at how this concept is used in differentiation. So if y is a function of u and u is a function of x, then the equation used to find the derivative of that function y is dy dx equals dy du times du dx. So if you have a function, and chain rule is used when the function has powers, has higher exponentials in the function. That's when we use chain rule. And the exponentials, it embraced the whole function. If the exponential is embracing the whole function, then we apply chain rule to find the derivative of such function. So if you look at this equation here, dy dx equals dy du times du dx. Now, how do we find these derivatives in this equation? So first, our y is equal to f of x, which is the function. So you take note of this. Our y is always equal to the f of x. It's the same. Y is equal to f of x. So if you want to find the derivative of y, it's either dy dx. That's finding the derivative of y with respect to x. So f prime is the same as y prime, which is the same as the dy dx, which is the derivative of the function. So if you consider this problem, given that y, which is equal to f of x, equals into bracket 4x cubed plus 7x bracket close to the power 3. So now here, this exponential 3 is embracing the whole function. It is embracing the whole function. So therefore, you have to apply the chain rule to be able to find the derivative of such function. So we apply chain rule to be able to find the derivative of the function. Now let's look at how we apply the chain rule to such problems or such questions. So firstly, the terms in the bracket, we denote them as u, or we equate those terms in the bracket with u. We equate it with u. You can use any different alphabet, but mostly we denote it with u. So after denoting the term in the bracket with u, your y therefore becomes u to the power 3. Your y therefore becomes u to the power 3. So after denoting that term in the bracket with u, you are supposed to find its differential. You are supposed to differentiate it. So the differential of this becomes du dx. The differential of this becomes du dx. So now we are applying differentiation here. So we take 4x cubed, which therefore becomes, we separate the 4 from the variable. Then we bring the 3 in front of the variable. We subtract 1 from the exponent, as we know in differentiation. So we differentiate this. Then we differentiate the second term of u, which is 7x. So we're having 7 into bracket 1x. Then we subtract 1 from the exponent. So after finding the derivative of u, we're getting the u dx to be equal to 12x squared minus 7. And we know that any variable or any number to the power 0 is 1. So 1 minus 1 is 0. X to the power 0 is giving us 1. Hence, we're having 7 here. We subtracted 1 from 3. It gave us 2. Then the original 4, which is the coefficient of x cubed, and the 3 which we had from the exponent that we brought, multiply the 4, give us 12. So this is the derivative of u with respect to x. So after finding this derivative, we come to our y. Our y then becomes u to the power 3. Since we replaced the terms in the bracket with u, our y therefore becomes u to the power 3. We are supposed to differentiate these two. So we differentiate y with respect to u. So we are having 3u to the power 3 minus 1. The exponent will become a coefficient. We subtract 1 from it. So we're having dy du to be equal to 3u squared. We're having dy du to be equal to 3u squared. So now we found dy du and we found du dx. So we have to substitute them into the equation to get dy dx. So now let's look at a typical problem then we know how to apply the chain rule in finding the differential of a function. So the question says, find the derivative of h of x, which equals, into bracket, 2x cubed plus 2x minus 1 all to the power 4. So this is the function. Let's solve it together. So first, we state the equation of chain rule, which is dy dx equals dy du times du dx. Dy dx equals dy du times du dx. We have the equation. Now we will place the terms in the bracket with u, therefore leaving us y, which is equal to h of x, to be equal to u to the power 4. So h of x is equal to y is equal to u to the power 4. We replace the terms in the bracket with u, so we're having this. Then now our u, which we replaced, is 2x cubed plus 2x minus 1. So we have to find the derivative of this, then that. So we find y with respect to u, then u with respect to x. So let's look at how we go by the steps. So first we're having dy du. That's the first one we are finding. So find the derivative of that. U squared will give us 4u to the power 4 minus 1. Multiply the exponent and becomes a coefficient, then subtract 1 from it. So we're having dy du to be equal to 4u cubed. Having dy du to be equal to 4u cubed. Now we look at u with respect to x. We find the u dx. So the first term, which is 2x cubed, we bring the 2 in front. Then the exponent becomes coefficient. The exponent becomes coefficient. We subtract 1 from it, which gives us 2 into bracket 3s to the power 3 minus 1. Then the next term, we separate the original 2. Then the exponent, which is 1, becomes the coefficient. We subtract 1 from it. Then the 1 becomes 0 since it's a constant. So we will not differentiate this. It's automatically 0. After finding the differential, we're having the u dx to be equal to 6x cubed minus 2. We're having the u dx to be equal to 6x cubed minus 2. So now we have our dy du, we have our du dx, we have our du dx. So we substitute these two into the equation, then we find the derivative of the function. So substituting it into the equation, our dy du was found to be 4u cubed and the u dx to be 6x squared minus 2. 6x squared minus 2. But if you look at the derivative, it should be with respect to x. But in the equation, we have an odd variable, which is u, meaning we are supposed to replace the u that we did earlier on in here. We're supposed to substitute that u in here. So therefore, we are doing the substitution. We bring the u, which is 2x cubed plus 2x minus 1. We will bring it here into this equation. We place it back. Then after that, we simplify to get our final answer. So 4 will multiply through all the terms in the bracket. So now we have dy dx to be 8x cubed plus 8x minus 4 all to the power 3, multiplying 6x squared minus 2. So this is the final answer. And when this, we leave the multiplication as it is. We don't break it down to find the simplest form. We leave it as we see here. So this is how we go by to use the chain rule to find such functions. Use the chain rule to find the derivative of such functions. Now let's look at another question. So we have find the derivative of f of x, which equals 1 all over into bracket x to the power 7 minus 4x squared all to the power 4. So let's solve this question together. Firstly, we are supposed to eliminate the fraction in the function. We're supposed to take off the fraction in the function. So doing that, the 1 goes off and leaves us the exponent to be negative. So the exponent, which is 4 here, now tends to be minus 4 since we took off the fraction. So we're leaving our function to be y equals into bracket x to the power 7 minus 4x squared all to the power minus 4. So now this is our function. We state our chain rule equation, dy dx equals dy du times du dx. So we are supposed to replace the terms in the bracket with u, then we have our new form of the function. So if we replace the terms in the bracket with u, we have y to be equal to u to the power minus 4. Have y to be equal to u to the power minus 4. Then u becomes x to the power 7 minus 4 s squared. X to the power 7 minus 4 s squared. So this is our u and our y after the replacement. So now let's find their corresponding derivatives. So finding the y du, we are getting minus 4 u to the power minus 5. So you subtract minus 1 from minus 4. Then minus 4 becomes the coefficient of u. So leaving the y du to be equal to minus 4 u to the power minus 5. Then we find du dx. So find the derivative of this, which is du dx. So the first term, which is x to the power 7, we find its derivative. Then 4s squared, we find the derivative, leaving us 7x to the power 6 minus 8x. We have only 7x to the power 6 minus 8x. So after finding the derivative of u with respect to x, then y with respect to u, we do the necessary substitutions. So we state the equation again, which is dy dx equals dy du times du dx. So we come to do the necessary substitutions here to find the derivative. So dy dx therefore becomes minus 4u to the power minus 5 times 7x to the power 6 minus 8x times 7x to the power 6 minus 8x. So we have to substitute back the u that we replaced. We substitute back the u we replaced here back into the equation. So doing the substitution, we're having minus 4 multiplying x to the power 7 minus 4x squared all to the power minus 5. So this is what leaves us after doing the substitution. Minus 4 into bracket x to the power 7 minus 4x squared all to the power minus 5. Now we have to change the equation back to its fraction. So we have to eliminate the negative exponential. So when we take that off, we're having minus 4 into bracket 7x to the power 6 minus 6x all over x to the power 7 minus 4x squared all to the power 5. So the coefficient of its bracket comes up, becomes the numerator. Then this factor multiplying them two becomes the numerator. Then this part, which has the negative fraction, becomes the denominator. So take note of how we change the final answer into the fraction form. So now this is how we use the chain rule to find the derivative of such functions.